Hi guys, happy Thursday. We have almost made it through a week of e-learning. I hope everything is going well. Please note that I'm praying for you. I'm thinking of you guys. This has just been a super weird time. And I just pray that you guys will be able to find peace and be able to find hopefully comfort in your own home and get to have this time of taking a deep breath, slowing things down. If you guys have any questions or any concerns about classes, about my class, about content, about how things are working, please message me. My computer's with me all the time. My phone is with me all the time. And I really just want to help you guys. So to recap what we learned last time, we learned about single replacement reaction. So this is when we have one element in a compound, and that element switches with another element in that compound, and we end up with two different things. So that's represented by A plus BC yields B plus AC. So we talked about where if A is a metal, it's going to bond with a certain type, and if A is a non-metal, it's going to bond with a certain type. So let me go ahead and hide that for a second and bring this back. Awesome. So we gave some examples. We talked about zinc and copper chloride. And so what happened was zinc came in and stole chlorine and kicked copper to the side. So zinc was alone by itself, and at the end of the reaction, it wasn't. At the beginning of the reaction, chlorine was attached and bonded to chlorine, and now copper is kicked to the curb. So similar to that lab that you guys watched through Nearpod in the last lesson, where you saw the copper formed at the very end, where copper was bonded with chlorine to begin with in that blue solution. And then when there was energy added and another substance was added, you got to see copper become all by itself, and it was no longer bonded to chlorine. So that's a similar example here. So today, get through all this. Today we're going to be talking about double replacement reactions, okay? So instead of a single thing being swapped, we're going to have two things being swapped. So in a double replacement reaction, by the way, totally forgot to tell you, please get out your interactive notebook, turn to the next clean page, and label it double replacement reaction notes. I'll give you a second to do that. I'm so silly. And okay. So back on it. Let's take some notes. So double replacement reactions swap elements. Okay, so between two compounds that react together. So I have two compounds that react. I don't have a single element in a compound. I have two compounds, okay? And each compound has different elements in it. So what's going to happen is the elements are going to kind of rearrange and switch around. So whatever elements I started or whatever compounds I started with at the beginning are going to be completely different at the end. So this is represented by A plus B. I'm sorry, scratch that. AB plus CD. And then when we add energy, yields AD plus CB. So in the beginning, A was bonded with B. But at the end, in the products, A is bonded with D. And the beginning, in the reactants, we had C, which was bonded to D. And at the end of the reaction, C is now being bonded with B. So they switched dancing partners, okay? I don't know if you remember in class, I guess a week ago now, maybe 2 weeks, when I introduced all of these different reactions to you, I said that a couple came in and another couple came in and they left with a different date. Okay, there's two switches going on. So here's an example. This is a really goofy picture, but it's really, really good at explaining what's going on. So I have this fatter-faced man with a dark hat. I have a thinner-faced man with a white hat. When I add energy, the larger-faced man now has the white hat, and the thinner-faced man now has the black hat. So the black hat was originally on this guy, but at the end, it's now on the thinner-faced guy. Okay, so it's the same thing. We're having two things are switching at the same time. The white hat and the black hat both switched at the end of the reaction. So let's talk about some different types. Here's an example. We have magnesium oxide. Okay, so magnesium and oxygen bonded together, plus calcium and sulfur being bonded together for calcium sulfide. So what do you think will happen when we add energy to magnesium oxide and calcium sulfide? I want you to take a guess. Think. Double displacement. Two things switch. Okay, let's talk about it. So we have magnesium oxide over here plus calcium sulfide. When we add energy, let's see what happens. Magnesium was originally with oxygen. Now magnesium is with sulfur. Calcium was originally with sulfur, and now calcium is with oxygen. So there was two switches, sulfur switched and oxygen switched. There was a double switch, double displacement, or a double replacement. So we have two completely different compounds. We have all of the same elements. We started with magnesium, we end with magnesium. We started with calcium, we end with calcium. We started with sulfur, we ended with sulfur. We started with oxygen, we ended with oxygen. Because that is what meets the law of conservation of mass, right? We always have to obey that law. But I have completely different identities. Magnesium oxide is completely different than magnesium sulfide. Calcium sulfide is completely different than calcium oxide. So we have completely different new elements in a double displacement reaction. And again, this is a general formula. AB plus CD yields AD plus CB. So in this example, A could represent magnesium and B could represent oxygen. And we will add carbon, which could represent C, which would represent calcium, and D, which would represent sulfur. So magnesium is now with D, and D was sulfur. So magnesium and sulfur, AD, are right here. Okay, so this is an example of a double displacement reaction. Okay, so let's talk about some examples. So here's an example. We have two solutions that react to form a precipitate. Everybody say precipitate, not precipitate. Okay, this is precipitate. And a precipitate is simply just a solid. So anything that is a solid that is created and combined to create a solid in another solution. So let's talk about an ionic solution plus an ionic solution. Okay, that will give us an ionic solution and an ionic solid. So I want you to think about the lab that we did last class. Okay, last class, as in the Nearpod. You had a solution and you added a solid, and what did you get at the end? You got a solid and a solution. So kind of similar here, but this is when we have two different solutions or a liquid, we get another liquid. Okay, completely different identifiable liquid, and we get a solid. Okay, still represented by AB plus CD yields AD plus CB. So an example is when potassium chromate and silver nitrate react. Okay, so we have a compound plus a compound. They form a red precipitate or a red solid. Precipitate means solid. They form a red solid and silver chromate. So notice before in this word equation, silver was bonded to nitrate. Now silver is with what? It's with chromate, okay? In a solution of potassium nitrate, same thing. Potassium was originally with chromate. Now potassium is with nitrate. So this is the equation. So we have potassium chromate plus silver nitrate yields silver chromate plus potassium nitrate. So we have that switch. If you think about the hats in that image that you saw a few slides back, there's two switches going on, okay? Just like in that picture, we had one white hat move, and then we also had the black hat move. There are two moving parts, just like in here, we have two moving parts. So this is what that looks like. Isn't that crazy? So we have two different solutions. Another solution is created down here, and then we have this red solid stuff. You can see it rising onto the top of it. So this is silver chromate. Okay, and then we have silver chromate, and then we have, potassium nitrate, which is really, really cool. It kind of looks like blood, which is really crazy. So you guys are done with notes for today. So go ahead and pause this video, and you are going to go ahead into the Nearpod and complete the lab and quiz for the day. Bye, guys. Have a great day.